So here we have one polynomial grouped together and another polynomial grouped together, and they're being added together like this. And we just need to go ahead and basically combine the like terms. So you could rewrite this entire thing without any parentheses at all if you want to. There's no need to when it's addition because you are just going to go ahead and combine like terms. But, so this m squared goes with this m squared. So negative 3 and 4 makes a positive 1 m squared. No reason to write the 1. This m is like this m, so they combine to make negative 4m. And then this 8 and this 2, they make 10. So as long as we're not changing the powers on things, when we're adding and subtracting, we're putting like terms together, we're not tempted to put this with this in some weird way, it's not a big deal. In this case too, there was not a subtraction sign here, so I didn't have to worry about distributing anything through. So really, for these types of problems, they're pretty basic. Just kind of have a little red flag in the cases where you're subtracting and make sure that that subtraction gets through to everything like we saw in the previous example. Whoa. So if we have something like this, here's a multiplication problem, right? So we're going to use some of our skills from the last chapter about how to deal with multiplication of things with the same base, and we're also going to go back to our middle school days and use the distributive property. Because what's going to happen is this 10y to the 5th is going to distribute to every part of the inside of this 5y to the 4th minus 4. And we're just going to take it like two separate problems. This thing multiplied by this, we'll do the coefficients. 5 times 10 is 50. And then y to the 5th times y to the 4th. We'll add those exponents together, y to the 9th. And then I'll take this 10y to the 5th and multiply it by this other part over here. So 10 times the negative 4 makes negative 40, and then that y to the 5th is just going to stay y to the 5th because there's no other y's inside of there. And that is how we're going to do it. It's basically the distributive property mixed with those properties of exponents that we learned about in the previous section. We're not going to combine like terms. Well, we would combine like terms if we had them, but there are no like terms here. These are not alike. We can't put them together. That's the end of the story.